So welcome to our next tutorial demo session. This time this is the first tutorial showing you how to work with Docker containers, and we'll start with something very simple. As I mentioned in my lecture, the first step is to set up an account on Docker Hub. I have already registered to this account, and here it is. It looks like that at the moment. And my goal now will be to firstly create the image, next push this image into the Docker Hub here to the repository, and finally pull it and run it locally from another machine. So let's start with the first step, which is creating a new repository. For the purpose of this course, I'm gonna create the repo, which I'm gonna name ml underscore tests. And as you can see, I have two options here, whether to make this public or private. In a free account, you have only one private repository visible only to you. Other repositories are private. So for the purpose of this course, I'm gonna make a public repo. So this is this. So now let's create this repo. And as you can see, this is the instruction for me, showing that whenever I would like to push the image from my local computer to this repository, you should use this command, docker push. Andrzej Wodecki is the name of my Docker account. It is here, as you can see. Next, slash ml tests. This is the name of the repository I have just created. It is here. And then I have a colon with a tag name, which is the name of the image. So we have it prepared. So now let's go to my first folder with the demo. It is here. We are in the folder Organization Simple Application Container Management. In order to work with that, you need to have a Docker daemon running. So remember to install the client on your computer. That may be a software which runs in the background on Mac or Windows or Linux, or that may be a process running in the background. So it's up to you how to start this container, start this Docker daemon. So let's have a look at our files we have here. As you can see, I have 3 folders. So I'm gonna change the folder to now demo version, and let's check what do we have here. So what do we have? We have a simple Python script, hello world, and the Docker file, which looks like that. From Python 3.8 minus slim minus busted. This is the simplest distribution of very light Linux. Copy all the content from this folder, current folder, to the image, and then run the command. So this is that. In order to run this, in order to build the Docker image, we need to run this command, docker build ---- tag first application with the Docker file. As you can see, all the content from the current directory. So let's do it. Okay, so it's done. So we have the image built. In order to run this, we need to type simply docker run, and that's gonna be first application. So we just simply invoke the name of this application, and let's see. Yeah, it works. So we are done. So we have created the image and then run the container. So we are now ready for a bit more advanced example. As you can see here, I have a runpy script which By the way, I need to change this interpreter to our content environment. What it does, it reads some training data from our data folder, and next it prepares this data for modeling. Next, instantiates the linear regression model and fits the model. Finally, it exports the model and evaluates that on evaluation dataset. So this is just a very, very basic example of machine learning code, extremely basic ones. So before we make a Docker out of that, let's test whether it works. Yep. So we can see all the most important printouts on the screen. So now the next step is to build the container. We are going to use this with the following command: docker build --tag train eval _eval. So train and eval. That's gonna be the name of our Docker image. Then, as you can see, you need to be very careful. This is the space here and the dot, which says, okay, let's take all the data from this current directory, and Docker file should also be there. So let's test it. Okay, so it's done. But look carefully what's in the Docker. At the moment, I use a bit different Docker image. This is Ubuntu. It's a bit heavier than the slim image we used previously. It's around 25 megabytes. There are plenty of different images of Linux systems. The most popular are the lightweight one, but for them it's close to impossible or very difficult to install the libraries like pandas, numpy or scikit-learn, which we use here. It's very, very fancy. So my advice is the following. It's not always that run pip3 install and here run pip3 install -r requirements, where in our requirements we have, as you can see, pandas, numpy, scikit-learn, etc. That command will not work for all the Ubuntu or Linux images you use here. Okay, so in case you encounter some problems, it's much better for you to use a bit heavier 25 megabytes image of Ubuntu than this lightest one like Alpine or some other. That's for the situation in case you would like to use your Docker as a combo which contains all the libraries within itself. In many use cases, it's just used to as a Linux engine with all the libraries installed on the host server. So it depends on the scenario. Okay, but still, the next step, having this, we can run this image. So let's try docker run. -ti means running it with detached mode, and with the comments, all the comments displayed on screen. So let me type this. Let's see whether it works. Yep, it works perfectly. So, interesting fact. We are going to talk about the Docker management in a second, but let's have a look here at our Visual Studio Code. As you can see, I have a very handy plugin which requires some extra installation, but it's still a question of a second to install it. I have images, containers here, yes, so I have different images created during our course, but I have also containers, corresponding containers. If you are looking for this container precisely, you will see that it's not running. Why? Because after this command is run, the container is automatically stopped. We're going to see this in a second. So now let's talk about the container management. Here in the next demo, we have a very basic example of the application which, look, simply checks if there is a file with containing data frame on our data folder, and next generates some random numbers, multiplies this data frame if it exists. If it does not exist, it creates one, yes, multiplies this by the number and saves this as the output file. That's a very, very basic application, and whenever you are going to try a new technology like Docker, which if it's new for you, I really recommend you to start with something extremely simple, just to have full control over the process from the technological point of view. So we are going to take this example and proceed with this to much more complicated versions later on. Let's run it. So let me activate our ASI environment and let's try it. So I will just simply write. Yep, as you can see on the printout, it creates a new data frame, generates a random one, next generates the random number and transforms that original data frame to the transformed data frame by multiplying this by this random number and prints out the completed message. Let's have a look. Yep, it generates a new data frame, as you can see, and a new output data frame. So that's a very, very basic example. And now let's use this example to talk about how to manage images and containers, which in some sense are processes which may have different status in our computer. We're going to see how to check whether they run or not, to clean them, etc. So let's start with the Docker build. Okay, so let's build the So I built the app with the name tag v1 using all the assets which are in the current directory. Yep, it is here. Let's have a look at the Docker file. As you can see, I use this Ubuntu as previously, and I install Python 3 and pip and update them using apt-get from Linux. And finally, I set up the workday as the app. This is the internal folder within the Docker. Copy all the files to this Docker, install all the requirements, and run app1.py application, which is, by the way, already here because I have copied that into our local image. And requirements, as you can see, this is only the very simple basic requirement. There is no training, so I need only the very basic pandas here. So now we have our container build. We can check if it is in our system with a docker images command. Yes, as we can see, we have Docker with the name v1, tag v1 with the repository local repository f1, which was just created. And now we can simply run this. Before we run this, let's check with the command docker ps whether we have any running container. It's like in a Linux system. As you can see, there is no active running containers at the moment. We can also check all the containers in our system, because containers may be different states. They may be running, or they may be simply be stopped. So let's have a look. I have it clean because I have just simply pruned them with docker container prune command previously. So now we can run our container with the command docker run -di, just to have it in a detached mode, and provide the on-screen messages. Okay, so let's give it a try. Yes, it's here. So now let's repeat our actions. Docker ps, nothing is running, but if you docker ps minus all, we can see that we have a single container which ran 11 seconds ago, so just now. It has some very interesting name, reverend underscore heads, but it shows that we do not have any container running, but we have this container in our system. You can also check it out here. As you can see, we have images section here. This is app 1, image and containers. As you can see, this container has already stopped. So this is the first message for you. You may have different images, may have different containers in different state. So let's continue with our analysis. Let's try to run this container once again. It's run, and repeat these commands once again. Docker ps shows us there is nothing running, but docker ps minus a shows us, come on, look what happened. Very interesting situation. We have at the moment 2 containers in our system. So that's may, from your point perspective, be quite an unusual behavior, because each run creates an extra container in our system which is stopped. So it's not like in a typical Python run where you run the script and it's done, so it disappears from our system. No, it stays there. So we need to be aware of this, because sometimes we have plenty of distance containers. It may be huge, so we need to take care, make housekeeping, maybe clean them, etc. So that's because of this command here. We are going to copy this with this later on. This command tells Docker just to run it, and if the run is successful, keep the container but stop it. Yes, so that's the command. Sometimes we need to take care of this, about this, to use in a different way. I'm gonna show it to you in a second. Okay, there is also another option where we can restart an existing container without creating a new one. So that's a kind of the workaround. So having this container in our list, instead of this command which creates a new container, we can type something like docker container start -a, and now I need to use this container ID. So let's have a look now. Yep, it ran. And now if we ask for all the running containers, it's empty because it has completed the job and stopped. But if we ask for all the containers, look, now it's much better because we have only 2 containers. So we have no extra containers added to our system. So once again, be aware of that. If you want a limited number of containers running in the system, use rather Docker containers than Docker run, because Docker run creates a new container. There is also another option. Look, you have this container ID. We can execute a command inside a container. Container, as you can see here, contains Ubuntu system, and Ubuntu accepts different commands. So we can run something like that: docker exec. Yes, this is the docker command. Once again, -ti, and now I will type the container ID. Remember, this container is already stopped, but it is in our system. And now the command, shell command. So I say, okay, docker go and exec a shell command sh in this container with this ID, and this command I'm gonna use is this one, ls, list all the scripts there. Oops. It's not running, so I need to run this. This is possible only when the container is running. So, I made this error, by the way, intentionally. So how to keep this container running? We need to either delete the last command here and recompile the create a new image itself, yes, with the version 2, or we can run the container with the bash command at the end. So we are going to use this. So we just simply use docker run -ti. I'm gonna use this image as previously, v1, with a bash command. Yep, as you can see, we are now here in the root folder of this command. So let's have a look. We have all the files. So we have entered the image and the container to the Linux system. We can now change the folder to the data folder. Let's have a look what's here. It's there. Okay. So now let's have a look once again just for sanity check whether we have some containers running. No, there is no containers running. And it's here. If we run this command now once again in this bash file and check a new terminal now, okay, and now ask docker ps, as we can see we have this container running. So at the moment, if we keep this shell docker bash command running, it will keep the container running. So once again, as we can see, we can use this either from the command line interface. We can manage those containers either from the local command line interface or from this Docker plugin. As we can see, I can see this image running here. Yes, it's in green, so it's running. There are plenty of options. What we have covered now is firstly I showed you that we can, as previously, build the image. Next, list all existing images in our system. Next, we can run the image to create the container. Each run creates a new container. If we have this line here in the Docker file, after each run, the container is stopped but exists in our system. If we want to avoid such a container creation after each run, we should rather call docker container start. Yes, so that's another option. Moreover, I shown you that we can enter the shell of the container using the bash command, but in order to do this, the container needs to run, or we can execute, we can execute the shell command from the container, but for that we need this docker container running. But we can make it running with docker run bash command. So these are the basic operations, the most important operations on containers, which might be useful for you in the future. And in our next tutorials, I'm going to show you how to manage the data transfer between the container and the host and the containers themselves, which will be very important for pipelining, yes, for making a pipelines out of the Docker files. Thank you. See you in a few minutes.